Okay. All right, so objective 31 and 32. So it is 2 for 1 Wednesday. Let's see what we can remember about objective 31, like terms. Like we've never seen it before. What do you remember? What are like terms?
Like numbers are like terms, and numbers with an X are not like terms.
Numbers with an X are like terms. If you have a big old expression, what you want to do is you want to find the terms that you can put together. Those are going to be the like terms. So the terms that you can combine together are the like terms. So like terms are terms or pieces in an expression. Like Coleman was saying, sometimes you have like a 3x and a 5x. Those are both x terms, so they can be put together. Now the next thing was the most basic like terms. That's kind of what you were going to say. The most basic like terms are what?
Just numbers.
Just numbers. No letters on them at all. If you see anything that's a number, Dalton, that does not have a letter on it, it's going to be a like term. It's a number. I don't care what it looks like. So the most basic like terms are just numbers. Simple numbers. No variable. So if you see anything that does not have an X on it, it's a number. I don't care how ugly it might look, it's just a number. Give me a number, Desiree. 5. 5's a number. Give me a number, Jaden.
2.
-2. Give me a fraction, Coleman.
1/2.
1/2. Give me a number with a decimal, Jacob.
2.2.
2.2. Preston, give me a number, give me a fraction.
5/8.
5/8. -5/8. Let's go, Morgan, give me a number. And give me a fraction.
2/3.
3 2/3 together. 3 2/3, just a number. And then I got one more. For some reason I put a whole bunch on here. So, Macy, just give me something. 7. Yeah, there we go. 7. These are all numbers. They all look different, but they're all like terms. I could go in my calculator and I could add all of these things together and combine them. I could say 5 minus 2 plus 1/2 plus 2.2 minus 5/8 plus 2 3 2/3 plus 7. And I get an answer. They go together. They don't have an X on them. They're like terms. Now the other like terms are terms with variables. But here's how you know that they are like terms. They have the exact same variable situation. Underline that. Exact same variable situation. So your most basic like terms are what?
Like or just numbers.
Numbers. If you got an expression, anything that is a number that doesn't have an X or a Y or anything on it is a number. I don't care if it's a fraction or a decimal or what. If it doesn't have an X on it, it's just a number. As ugly as it may be. Could be ugly like 2.2. Could be fraction ugly like -5/8. Those things still go together. You can still just add those. Other terms that have variables, if they have the exact same variable situation, they're like terms. What I mean by that is if you have 7x, it has to go with another x. So 7x and give me something else that has an x.
8x.
7x and 8x would go together. 7x and 8x. If I had 2y and -6y, those would go together. But those are obvious because they're both just 7x and 8x. Obvious, those are x's. The variable situation could get messy and ugly. Instead of just x's, a piece might say 2x to the 4th. That goes with another what?
2x, 5x to the 4th.
5x to the 4th. So I could have maybe minus 5x to the 4th. Those are like terms. But it could get messier than just x to the 4th.
xy to the 6th.
xy to the 6th. If I had 7 xy 6's, I have to put that with another xy 6, like 2 xy 6's. So whatever the variable situation is, the variable situation on this was just x. Here was just y. This one was x4. Notice that the 2x4 doesn't go with the 8x. they're not the exact same situation. So this is not a like term to this, even though they both have the letter x in them. And then this one has x6. It only goes with other xy to the 6th. All right, let's look at the back side. Like terms, just kind of like what you said. But here's a collection of them for you on the back. 3x and 4x go together. 2y and 3/5 y are like terms. 9x squared y4 goes with 16x squared y4 because they're both x squared y4s. X squared y4s. 7 and 3/5 x to the 5th goes with 20 x to the 5th. Even though this big number out front looks way funkier over here, it's still an x5th, and this is still an x5th. So that's like terms. All right, the number that you see attached to the left of the variable situation, you can see the variable situation. It's here, it's here, it's here. The number to the left, do you know what that is called? Okay, let the records show that no students know what that number is called. So today we learn, and we won't forget. Any guess? It starts with the letter C. C-O.
Coefficient.
That's it. So you've heard the word before. The big number to the left of the situation is called a coefficient. So you need to know that. So when we communicate in algebra, you go, oh, coefficient. He's talking about here. What's the coefficient of this one?
4.
4. What's the coefficient of this one?
3/5.
3/5. And the ugliest one I got up here, what's the coefficient of that?
7 and 3/5.
7 3/5. So the number attached to the left of the variable situation is called the coefficient. Coefficient. It's the big number to the left of the situation. We need to know what coefficient is because putting the coefficients together is how you combine like terms. For any two like terms, we can just combine them by adding their coefficients. Add their coefficients. So when I got a 6x squared y and a 4x squared y, what is the coefficient on this one, Jacob?
6.
6. Dalton, what's the coefficient on this piece? 4. So this is an x squared y and this is an x squared y. If I want to put these two together, I'm just going to add their coefficients. I got 6 of them here and I got 4 of them there. So how many do I have total? I got 10 of them. And of them, I mean I got 10 x squared y's. So I just add the coefficients together because I got 6x squared y's and I got 4x squared y's. So together I've got 10x squared y's. Now this sheet you saw the other day, there is a bunch of numbers. You don't have this sheet. There's a bunch of numbers up there. Now what are the most, these are all sorts of terms. What are the most basic like terms?
Just
Just numbers.
Just numbers. So I want you to see if you can spot some just numbers.
2.
Okay, I see 1/2.
15/7.
We're 15/7. Do we see any other that are just numbers?
3 1/8.
3 and 1/8, so way down here, high and over here. Any other just numbers around there?
6.54.
Oh, where's that at?
And
That's
17.
up.
6.54 and 17. You notice none of those things that are circled have letters with them. So they could all be combined together. So somehow I just want to string them all together. And is that it? There's no more numbers that are no letters. Okay, so then let's look at another one. Just start at the top of this 9x right here.
2x.
9x, I see 2x.
5y.
Oh, nope. We need, what do we need for it to be a like term?
And
An
x.
X.
An x, just an x. It could be 3x, 7x, 10x, 11x. It's
x5.
different. It's different. It's too different.
It has.
Oh, okay. Never
Yeah, x5s are only going to go with x5. Do we have any other x's out there?
Scroll up a little bit. 7x.
7x. There we go. So put all those together. What do you see next?
2x, y, 3.
Okay, wait. I
4Y.
4y and
15y.
are there any other y's? No. Okay, Jacob, which one are you saying?
2xy.
2xy
To the third.
foot to the third. Okay, 2xy to the third. Do you see any more xy to the thirds out there? No. So we don't have any like terms for him, so I can't connect him to anything. So this one's just kind of dead in the water. What about y4s? Do you see any, I'm going to put diamonds on these ones, I'm out of colors. Do you see any more y4s?
Down at the bottom. Yeah, 21 by 4.
Yeah.
21.
So you could put those together and make 24 y4s.
X to the
X
5.
5.
Yeah, the x to the 5s we were trying to put together a minute ago. That x5 goes with
X
X
5.
x5. Now, you've got 11x5 and you got x5. Notice that there isn't a coefficient on there, is there? If you don't see a coefficient, what is it really?
1x.
1. So this is 11x5s and 1x5, so together it makes 12x5s.
6x
Yep.
X
Six.
to Y.
squared y.
Goes with
X
X
squared Y. And then 9x full Y. And 6x full Y.
That was it. And you put them all together, and there was only one in the whole lot that didn't have any terms to go with it, and that was that. And so that is objective 31, identifying like terms. Okay. I don't know. Just totally missed.